Okay, so in the last video we looked at ellipses. We're going to take a look at a couple of different examples of what to do with an ellipse, how to write equations of ellipse and things like that. So for this problem, write the equation of the ellipse in standard form. Our vertices are 2, -6, 2, 12. Our foci, plural of focus, is 2, -1, and 2, 7. So the first thing we have to figure out is this an ellipse where the major axis is horizontal, so a long ellipse, or where the major axis is vertical, so a tall ellipse. You could just do a quick sketch. If you just kind of look at it, you don't even need to do the sketch, but I'll do a quick sketch of this. I'll do it over in the upper right. So if we were to have a graph, just doing a quick graph, x and y axis, 2, -6 would be up 2, or excuse me, right 2 and down 6. And then 2, 12 would be right 2 and up 12. If those are the vertices, that's got to be an ellipse. That's up and down, that's vertical, in order for the formula to work out. So that kind of gives us on the correct path. We could also look at the foci. The foci are at 2, -1, which would be there, and 2, 7, which would be there. So again, we can clearly see that that major axis is a vertical line, not a horizontal line. So I know what the standard form is going to be. I'm going to go up here and put that standard form on this board right now. And poof, with the wave of my magic wand, I erased my horrible ellipse drawing, and there is the equation. So we know that it's going to be y first because it's a vertical ellipse, and so that's why we have the y minus k first over a squared, x minus h squared over b squared equals 1. So we need to figure out h, k, a, and b. Remember what those are. H and k is the center, which I do not have currently. A is how long the major axis is, and b is the minor axis. Or A is the half of the major axis, excuse me, and b is half of the minor axis. So I don't have any of those. I have vertices and I have foci, that's it. But with the foci, if you recall from the previous video, with the foci I can figure out the center. Remember that the center is the midpoint of the focus, of the foci, excuse me. And so all I got to do is find the midpoint, and that's pretty easy. The midpoint is simply going to be x2 and x1 added together and divided by 2, and then the same thing with the y's. So I can clearly see with my foci that my foci are at 2, -1, and 2, 7. So if I do 2 plus 2 is 4 divided by 2 is going to give me a y-coordinate of 2 for the center, excuse me, an x-coordinate of 2 for the center. The y-coordinate 7 plus -1 is 6, and 6 divided by 2 is 3. And so there's the center. That tells me h and k. H is 2, and k is 3. I'm already halfway done with this problem because I needed 4 letters, h, k, a, and b, and I've got 2 of them. Next, I'm going to figure out a. That's the half of the length of the major axis is a, so I just have to figure out how long the major axis is. Well, the major axis is just going to be the distance of the between the vertices. Let's get that down in there. The length of the major axis there it is, the length of the major axis is the distance between the vertices. And I've got my vertices, and so I can easily find that distance. Again, the x-coordinates are the same, so realistically I don't have to go through the distance formula. You can if you want to, but since my x-coordinates are the same, I just have to figure out the distance from -6 to 12, and I can figure out that distance very easily by simply subtracting 12 minus -6, and so that tells me that that distance is 18. That's the length of the major axis, and so a would be half of that value. A is going to equal 9. Cool. So now I've got A, I've got H, I've got K. All I need to do is figure out B. B is the length of the minor, B is half the length of the minor axis. I don't have the minor axis, I don't have any information about the minor axis, but we do have that one other piece of information that we can use, the fact that C squared is equal to A squared minus B squared. Now, A is half the length of the major axis. B, which is what I'm trying to find, is half the length of the minor axis. Remember what C is. C is how far apart excuse me, C is how far apart the foci and the center are. So I know my center is at 2, 3. I know my foci are at 2, -1, and 2, 7. And so hopefully we can clearly see that C going from 2, 3 to 2, -1, or going from 2, 3 to 2, 7, that's just a distance of 4. So with that, I can now figure out what B is. I can simply plug into my formula, C squared. 4 squared is going to equal A squared, which is 9 squared, minus B squared, which is what I'm trying to figure out. From there, you can square them. 4 squared is 16, 9 squared is 81. You can subtract them and take a square root and figure out B. And if you do that, I trust that you can do that math. B is going to end up equaling the square root of 65. Now you can put that as a decimal. I'm not going to. I'm going to leave it as an exact answer. You can simplify that square root if you can. That square root does not simplify. 5 goes into 65 13 times, and so it's not going to break down at all. I don't care if you break them down or don't break them down, but I'm going to leave it as a perfect square instead of getting the decimal. So now that I've got all of that, I can go ahead and write my formula now. So up in the right corner, we've got our blue formula. I'm just going to replace all the numbers, all the letters that I need to replace with the appropriate numbers. So we start out with y minus k. K is 3. It's a positive 3, and since it's y minus, that becomes y minus 3. So there's y minus 3 squared. All of that is going to be over a squared. A is 9, so I need to square that. 9 squared is 81. Plus x minus h quantity squared, so x minus my h value is 2. The 3 and the 2 in those parentheses come from the center. Divided by b squared, that's why I left it as a square root. B is the square root of 65, so b squared will just be 65. And our equation always equals 1 because that's the equation for an ellipse. That's the information that we have, and that's how we write the equation based on information that we're given. So let's take a look at another example that starts us out a little bit differently. So in this example, we're going to find the foci, vertices, and center of the ellipse, and we're given the equation not in standard form. So I don't have any information about the ellipse outside of the equation, and the equation is not in a helpful form. I don't have h, I don't have k, a, b, anything like that at all. So that's the first thing I need to do. Once I can get this formula into the standard form, then I'll be ready to find all the things I need to find. Now, as far as is this a horizontal ellipse or is this a vertical ellipse, I don't know. There are ways to tell, but we really don't care about that. The math will figure it all out. When we set up the equation, when we're all done, we just have to make sure that the denominator, the bigger denominator of fraction goes first. So if x quantity, x minus h squared, has a bigger denominator, that goes first, and it's a horizontal ellipse. If the denominator for the y minus k portion is bigger, then that'll go first. That's it. So you don't even have to worry about it until you get to the end. So we've done things like this before with circles, and with parabolas, the same thing is going to apply. We're going to have to do some completing of the square. It means we have to reorder this thing. So I want all of my x's to be together, so I'm going to reorder it as x squared plus 6x. Let's restart that again. There we go. X squared plus 6x. I'm going to leave a little space. We know why we're leaving that space, and that's going to come into play soon. Then we're going to go plus 4y squared minus the 8y. Again, I'm going to leave a little bit of space. The 9, I don't want there. It's not an x, it's not a y, and so I'm going to subtract 9 from both sides. So that's really all I did, is I subtracted 9 from both sides, and I rearranged the order so that way I had all of my like variables together. Now it's time to complete the square. So that x squared plus 6x, that's pretty easy. It starts out with x squared, and so I can complete the square there by taking 6, dividing it by 2. 6 divided by 2 is 3, and 3 squared is 9. If that's a problem for you, go back to the circle video, and that will explain completing the square. Now, I'm not allowed to add 9 to one side of an equation, but as long as I add 9 to the other side of the equation, everything will be cool. So I'm going to add 9 over there. Now, for the y, I can't go ahead and just take 8 divided by 2 and square it because I have that 4 there. That 4 is going to screw everything up. So what I'm going to do is I'm going to go ahead and rewrite this equation again, but I'm going to deal with that 4. So I still have my x squared, I have my plus 6x, I've got my plus 9 hanging out here now, that's part of the equation. With the 4y squared, I can't just say, oh, I'll just go ahead and I'll divide by 4, no problem. You have to divide everything by 4 if you do that, not just parts of the equation, and we don't want to be dividing the x by 4 or anything else by 4. But what I can do, since I have a 4 in front of that y squared, I can factor that 4 out. Now we're in luck. The y also is divisible by 4, and so that leaves us with y squared minus 2y. If that weren't divisible by 4, we wouldn't care. That would just end up being a decimal. None of the problems in the book, none of the problems that we're really going to encounter are going to have that. But if that were, say, a 7, we would simply divide by 4, and instead of having a minus 2 there, it would say minus 1.75. Okay? I'm going to leave some space in this parentheses because I still need to complete the square, and that's what I'm going to end up doing next. So I'm going to leave a little space over here. On the other side, I'm just going to rewrite what I have because I want to put everything together in the end, and I want us to see how it all gets put together. So instead of combining it, let me just write it like that. Now, here's the tricky part. You may have seen this part in a different math class. I'm not sure. If you haven't, here we go. I'm going to focus on the parentheses, and I'm going to complete the square. So I take that negative 2, and I divide it by 2. That's negative 1. When I square that, that becomes positive 1. So I'm going to add 1. Now, I can't just add 1, so I have to do the same thing to the other side. Now, here's where we run into mistakes. Many students will go, oh, I'll go ahead and I'll add 1 here, and everything's cool. But it's not, because you didn't add 1. I know it looks like you added 1, but you didn't. You added 1 inside of a parentheses. If we were to clean up the right side, if we were to distribute on the right side, that 4 would end up multiplying all of those things in the parentheses, including that 1. So in reality, I didn't add 1, I really added 4. So I don't want that to be a 1 there, I need that to be a 4. So we have to be very, very careful and think about and look at what did we actually do. I know it looks like we added 1, but we added 1 in a parentheses, and that became a 4. Now we're ready to go. So the whole purpose of completing the square is because x squared plus 6x plus 9 can now be factored, and it can be factored as a perfect square of x plus 3 quantity squared. The 4 here is just going to stay there, and same thing with the y parentheses, that can factor down into y minus 1 quantity squared. On the other side, what it equals, if we put that all together, that ends up equaling 4. Now we have one last step. We want this equation to equal 1. It doesn't. It equals 4. That's an easy fix. If I simply divide everything by 4, then it will equal 1. And so when I divide this first x plus 3 quantity squared by 4, I have x plus 3 quantity squared over 4. When I divide the next portion by 4, the 4's will reduce. It's just coincidence that the 4's happen to reduce. If they didn't reduce, no problem, but they do reduce, and I'm going to go ahead and write it with the 1 underneath for my final answer. And then it equals, dividing 4 by 4, it equals 1. There's our equation, and now we're going to use that equation to get everything that we need. The first thing I'm going to grab is the center. That's super duper easy. X plus 3 quantity squared, y minus 1 quantity squared. The center comes from that, so our center is going to be negative 3, 1. And poof, like magic, there it is. Remember, when you're taking x and y for the center, you have to do the opposite of the sign, because the formula is technically x minus h squared, right? Next, vertices and foci. Well, I need to find a and b, and that's no big deal. Remember, 4 is a squared, so if a squared equals 4, that tells me that a is 2. I'm going to need b, so I'm going to go ahead and get that right now. B squared is equal to 1, so that means that b is also equal to 1. Remember our formula for c. C squared is equal to a squared minus b squared. And so if we plug those values in, we get c is equal to the square root of 3. All that information will then get us everything that we need. This is a horizontal ellipse because x comes first, it's got the bigger denominator, and so the x values of the foci in the center, they're the ones that are going to be different. The y values are all going to be the same. So, from my center, I can get the vertices very, very easily. The vertices are simply going to be a plus the center. Actually, a plus and minus the center for the x values. So if I add 2 and subtract 2 from my x values, my vertices will be at negative 1, 1 and negative 5, 1. C represents the distance the foci are away from the center, so I'm going to add and subtract radical 3 from my center, and that'll give me my foci. And there you have it. So when it's an x ellipse, the x values change. When it's horizontal, when it's a vertical, the y values would change. That's the only difference. So, your homework. Poof, there's your homework. Work on these problems, and if you have questions, feel free to text me. Until next time, have yourself a great day and stay safe.